today. For those of you who came out of say 61A or 88 or E7 at maybe like a B- level, that last method tilt could easily take you 10 hours. So just be aware. So get started on Project Zero if you have not. I hope you find it as fun. So today we're going to be talking about testing. And in particular, I'm going to basically show off more Java syntax, and we'll continue to move our way fairly quickly through the language. Okay, can you hear something now, Audrey? How's now? No? Let's see. Yeah, that's good. All right, good. Okay, so philosophically, when you guys write code, how do you know it works? What do you guys think? I don't know. When you're in 61A, how do you know your code works? Tests, right? Where do those tests come from? TAs, John De Niro, who knows? They appear from the heavens. Right. So the way you know your code works, at least as a student, is you submit to some kind of auto grader or you run some local test that someone else gave you. And what I'm going to try and do is I'm going to try and teach you how to do this yourself. This is really important. So in the real world, the way you know that your code works, I mean, you do some kind of testing yourself. Maybe that's just running it and watching a print statement go, or maybe it's something more formal like we'll do today. But the bottom line is, one of the most important things to becoming an efficient programmer is being able to write your own tests, because you're going to be breaking down problems, writing your own helper methods. And so it's extremely important that you're able to write tests that make your life much easier. All right, so now I should note that it is actually provably impossible for the most part to know that a program works correctly. In some limited circumstances, you can, but there's no universal way to know that a program works. There's a whole lot of deep CS theory on this point, like the halting problem. However, we can do some kind of test that will make life better. And this is going to be our new way. I'm going to try and make you better people so that you can build programs that you know work. And so this is the new way. Here you go. This is a montage that is put together, hoping to inspire you to write tests. Okay, ready? Here we go.
You are ready.
Okay, we need sound though. That's pretty important to the montage. Here we go again. You are ready.
You are ready to be taught the new way. Will you help teach me about this? What is it? A new way?
That's you. That's me. You can tell by the beard. Okay, there you go. So that's you. Okay, good, good. Anybody know that movie? Good, all right. No. Who actually knows this movie? All right, it's called Wet Hot American Summer. It's a fine piece of film. If you enjoy, say, I don't know, Nathan For You, that kind of thing, you'll probably like that. All right, I'm going to turn live transcription back on. So here we go. Okay. Let's turn that back on. Let's turn things on to good quality for watching and keep going. All right, so what we're going to do in order to teach you this new way, I need some kind of task. In the case of Coop and the clip we just saw, it was some kind of dance or karate thing. For us, it's going to be sorting. We're going to try and sort an array, and in particular, we're going to take an array of strings. So for example, if I have the string, he is the Aguyatis of Mr. Conkis, it becomes Aguyatis Conkis, he is Mr. of the in alphabetical order. That's going to be our goal. We're going to write this method, public static void sort string X. Okay. And again, we're doing this because I want to teach you testing, but we'll learn a little bit about how I think through problems along the way, and we'll reinforce some of the bewildering amount of Java syntax that I've dropped you into. So the old way, of course, is that there's some auto grader, and we have our sort method, and we give it to the auto grader, and it peers at our code, and it says, well, some kind of grade scope response, and you get some points, you don't get some points. That's the old way. And the new way is that you're going to write your own test sort. And I'm going to do something even crazier than this approach of writing our own test. I'm going to write the test first, and then we're going to write the code that passes the test, basically setting up a little challenge for ourselves. Okay. So let's jump in and do this. So we're going to go into IntelliJ, and I'm going to write the method at least. We're not going to fill it in. So I'm going to public static void sort string X. And this is supposed to sort the strings in alphabetical order. Okay, but for now, it's just going to return. It does nothing. In fact, you don't need to say that. It should do nothing. Then in my test sort class, and here I'm going to write a method which I'll call, I don't know, public static void test sort. Okay, and this tests the sort method of test sort. Sorry, actually, tests sort.sort. There you go. Okay, so how might we do this? Well, first I'm going to show you how awful testing can be if you approach it from the wrong perspective. And I won't spend too much time on this. What I'm going to do here is I'm going to actually go and generate a random sentence. So let's go to random sentence generator. Okay, is this the one I liked? There was one at random sentence generator. Was it? This is real nice. Random sentence. It was randomwordgenerator.org and had a sentence generator. There we go. Okay, so you guys make me a sentence. We're going to do 4 words. It is, sorry. Oh, the word 4 is not a word. Number of words, 4 words. Okay. They changed the system. Cool. I don't know what that means. All right, so they changed the system is going to be our string. And in particular, we're going to break it into little tokens. We're going to manually split it. I'm going to lowercase it to avoid any confusion. And this is what we're going to start with as our input. Okay. They changed the system. It's very inspiring. Okay. Cool. Okay. So this is going to be my input. I'm going to set up my input. And then I'm also going to set up another array, which I'll call expected. This is what we expect it to be. So in alphabetical order, that would be changed. RS system, E, they. I think that's right. Right. Okay, that's input and expected. Okay. Bad way to test. I'm only going to do this for about 30 seconds. I could do something like print I equals 0. Actually, first, I got to make my call. So I'm going to say sort.sort input. In theory, after this is done, input should be equal to expected. So if our code works, input will equal expected. So we could write some for loops to do this for us. We could say for int I equals 0, I less than input.length, I plus equals 1. That's how I usually write it in this class. Then I might do something like if input I equal blah, blah, blah. And then I have some print statements, something. But I don't want to do that. It's not a great idea for a number of reasons. One of them that I'll note just briefly, like doing input I equals expected I isn't necessarily the right thing to do. If I highlight this, you'll see string values are compared using equals, not dot equals. And this is some subtlety in Java that we'll come to at a later point. But the point is, like, if you're writing for loops and your test code starts becoming more than a few lines and it's not just totally obvious, then you run into the problem of having tests with bugs in them. And then you'll have to have tests for your tests, and or I don't know, you'll just get bewildered. So instead, I just want to show you, I'm gonna just totally cut off that entire approach and instead say there are built-in ways to test out whether or not our array is nice. So in particular, what I'm going to do is I'm going to use org.junit.assert array equals, and it'll look less ugly earlier, but I'm showing you the most verbose version first. And I'm going to put, actually, sorry, let me very careful when I start typing this thing. Okay, tell me my arguments. There you go. So there's a bunch of different possible inputs, but the point is that if you can't quite see this, maybe I'll try zooming here. The expected argument goes first, then the actual. Now, the reason you see a bunch of different methods here is, remember in lecture 1, we saw that in Java that if you want to be able to handle different input types, you need different functions, like we had the larger than function. And so there really are different functions that take a byte array versus a character array versus a short array and all kinds of things I've never taught you. Luckily, we don't really need to worry about that. I'm just going to say expected and input. Oh. So if I run this code now, which I will need a main function, of course. So in my main function, I'll call test sort. And you know what? I don't want it to have an argument x, sorry. If I call test sort, I don't know if you were wondering why that input was there, because I wasn't thinking ahead. So I run test sort. I get illegal start of type. Okay, I don't know what that means. Oh, because I had an extra slash. Okay, one more time. Okay, so I run this test and I get an error probably, and that's good. So we got an error. Exception in thread, main arrays first differed at element 0, expected changed but was they. All right, that's classic, right? Those are the man who's keeping things from different. They're blocking you. Let me check chat in case anything's broken. Oh, okay. All right, let's try resharing just in case. All right. Sometimes Zoom forgets how to, I don't hide the controls, then that blocks the Zoom viewers. Okay, so wait, there we go. We've written a test, and now we've set ourselves up for future success. Okay, any questions about this so far? So let me just compare what you might have done in theory to what I just did here. This is what a test might have looked like if I went through the whole exercise of writing the for loop. So I might have, the example I did before was beware of falling rocks. So here in this one, I iterate through the array. We check and see if they're equal. If they're not equal, then we say where there's a mismatch. We say like there was a mismatch at position I. We expected this, but we got that. The beautiful thing about org junit assert array equals is it does all the iteration for us. It generates this nice message for us so that we're not having to write all this stuff. If I tried to convince you as students who are trying to learn a new programming language and who are trying to learn data structures as relatively novice programmers, you would not want to do this. It just feels bad. You just want to get your work done. And you don't want to spend a bunch of time writing a bunch of for loops. So this better way over here with assert array equals, it just makes your life easy. Okay, so hopefully I've convinced you that writing tests is not hard. And so next I'll try and convince you that it is actually useful. Okay, any questions? Yeah. Right, okay, so question was, what is this? What's org.junit.assert equals? I didn't tell you, but I'll tell you a little more in a little while. And in fact, I'll show you later how you can get rid of having to do that. But just think of it as it's a really long function name that has dots in it for some reason. Yeah, good question. Other questions? Okay, I got a TA watching Zoom, so oh yeah.
So like so it's basically like a library that we use.
Yeah. Mm-hmm. Yeah, so it's a library in Java, and where it's stored, in case you're curious, it's in this jar file we made you download called JUnit Platform Console Standalone. And it has a bunch of functions in it. Cool. All right, good. So next we're going to actually write a sort method. Okay. So to sort, we need some technique for sorting. So I'll teach you your first algorithm of the class. Some number of you may have seen this in the past, but the sort I'm going to teach you is called selection sort. And the reason I'm teaching it is not because sorting is super important right now. We'll get back to it at the very end of the course, but because it needs some kind of algorithm to implement. And then it's modular and breaks down nicely into helper functions. So to selection sort a number of items, the idea behind selection sort, this is one, imagine you have a deck of cards. Someone gives you 6 cards and you need to put them in order. This is one way you could do it. Say you have a 6, a 3, a 7, a 2, an 8, and a 1, because you have some sort of counterfeit cards where there's a 1. So if we selection sort a list of n items, the algorithm is basically this. We find the smallest item. So 6, 3, 7, 2, 8, 1. Among all these numbers, what is smallest? 1. And look, it's even bolded and has a star. Perfect. So then we're going to stick it back at the front of the array. And that means 1 is in its correct location. And then we just repeat that process recursively, if you want to think about it that way. So we're going to now selection sort the rest. Okay, how do we do that? We find the smallest number, 2. We put it at the front of what is active. Okay, now only the last 4 are active. We find 3, we bring it to the front, and so forth. That's selection sort. Okay, find the smallest thing, put it in the front, don't touch it again. You can prove that this is correct using an idea known as an invariant that we'll talk about in lecture 4 briefly. But just trust me, okay, it works. I'll let you think about it for like 20 seconds. Convince yourself. So the helper functions, they almost write themselves, right? Find the smallest item, move it to the front, and then maybe some kind of recursive call. Okay. Any questions about this process? Okay, so let's try implementing this. So what I'm going to do here is I'm going to try and simulate as closely as possible as I can how you might do a test-driven development approach. Test-driven development is an idea where you write the tests first and then write the code. There's some people who are extreme practitioners of this, where it's like they must do it, and that's the only way they program. In practice, people do a little mix of both, but I'm going to show you a test-driven approach where I'm going to try and always write the tests first and try and convince you of the utility of this. So I'm not going to show the details of every little step here, so make sure that you are, if you're looking at the slides and not listening to me, watch the video that you're not watching. I don't know why I said that out loud, but there you go. Okay. So here we go. I'm going to try and write this code, and I'm going to start by writing a find smallest method. Okay, so we need some way to get the smallest item, and I'm going to start by writing the signature of the method. That's just the arguments that it takes. I'm going to say, let's imagine that we have public static string find smallest. That's just like my first idea. And again, I'm wearing my student hat, basically. I'm just imagining being a student. Returns smallest string. Okay. And for now, I'm just going to return x0 because I just don't care. And now I'm going to write a test. Okay. So let's write that test. All right, so public static. Actually, I'm going to copy and paste this one. And save myself a little time. We'll call this test find smallest. And this tests find smallest. Okay, so we just have an input. And this time, the expected, oops, not an, it's a string. So what's the expected answer? Good guess. That's if it was in order of length. Changed, yeah. So I guess we need to say what find smallest does. So I'll put this explicitly here. Note, the smallest string is the earliest alphabetical string. So apple comes before zoo, or how about arc comes before zebra. So it's, even though arc is let's try again. Let's see. Aardvark comes before zebra. So even though aardvark is longer than zebra, it still comes earlier because we're thinking alphabetical. Okay. What about all those things about capital letters and like commas and stuff? I don't care right now. Okay, let's not worry about it. Okay. So what I'm going to do now is I'm going to call sort.find smallest on input, and I'm going to set up a variable called actual. And if our code works, actual will equal expected. And now instead of using this assert array equals, I happen to know, it's a piece of lore that I'm donating to you, that it's called assert equals. And that's expected. In this case, we're going to put actual. And the reason I'm putting actual instead of input is the find smallest method doesn't modify the input. The sort method did. It like changes the input string in place. It doesn't return a new sorted list. It's sorted in place. So there's input. By contrast, down here, sorry about all jumping around, we have here actual. So this is our test find smallest. Okay. So now I'm going to put down here test find smallest and run it. We're going to get a preview of what's kind of lame about our code so far. So we run this thing and we get error, expected changed, but was they. Okay, well, test sort's getting in the way, so I'm going to comment that out. Okay, that's ugly. And I'll show you a better way in about 9 minutes or so. So instead, I'm going to comment that out. We're only going to run find smallest for the moment, and we get expected changed, but was they. And that's not surprising. We just return the first word out of the string. Right? We said they changed the system. We're returning they, so of course it is wrong. Okay. So what's great about this is now something we can try and do. We've set ourselves up for a task. It's like mini golf. We've constructed a little mini golf course. It's very small. We just got to knock the ball in about a foot, and then we can celebrate, and then we can move on to the next hole. We'll construct for ourselves and so forth until we can dominate the Saudi whitewashing golf tournament or whatever it is we're trying to do. All right. So here we go. Sorry if anybody here is a Saudi royal, but I have insulted your golf tournament. Okay. Anyway. Bad news, folks. Okay. That was supposed to be. Never mind. I'm gonna keep going the lecture. It was kind of a pseudo Trump impression, but in my own voice. Anyway, I don't know. I got nothing. Alrighty. So we want to make find smallest work. Okay, how do we do this? Okay, well, this is a normal pattern you've seen before. So I am going to work my way through the array and x.length. I'm going to set aside a variable called smallest string, let's say, or like, I don't know, best known smallest, or why not? I'm going to start by saying the best known or like current smallest. How about that? So the current smallest, we'll look at the first string and we'll say your smallest, and then we'll work our way through the array bit by bit until we see a smaller string, and then we'll replace current smallest. It's something hopefully you've seen in the past. Okay. So then what we're going to do is if current smallest is less than xi, no, other way around, sorry. If the thing we're looking at now, xi is what we're looking at now, is better than the current smallest, the thing I've set aside, then I'm going to say that current smallest equals xi. We've been looking through the array. We found a new champion. Xi is the new smallest thing. I'm going to set it aside and then we'll return current smallest. Okay, pretty good. Except we have one problem, which is if we hover over here, we see less thans cannot be applied to string. Okay, boy. Well, this is some Java garbage that we're upset about. If you're used to Python or whatever, this may be sad too. It will be. It's just like, why doesn't this exist? I don't know. Good question. Not sure. I have some thoughts, but they're beyond the scope of our day. So what do we do next? Do we post to Ed? No. What do Google? Correct. This is the correct answer. This is the right thing to do in this class. It's the right thing to do in your job. How compare strings Java? 100%. It's no joke. Seems funny, but this is the right thing to do. How do I compare strings in Java? Thanks for asking this question in 2011. Nathan H. Edited in January 23. Okay, so let's see. Is this the one I want? Let's see. This is about like equals. No, I don't want equals. Okay, let's try again. How less than strings Java? Maybe. Right. How can I compare two strings and define which one is smaller than the other alphabetically? Oh, wow. That's a good question. It's like I planted it 11 years ago. Sweet. So someone says you can use stir1 dot compare to stir2 if stir1 is lexicographically. Okay. Less than. Okay. Dictionary like ordering. Okay, that seems good. Oops. Okay, this is a good process. So, okay. So for example, if I compare A to B, it returns a negative number here, -1. They're equal to 0, positive number. This is weird, but I'm just going to copy and paste this in the code. Okay, which is okay because I'm writing tests. So I'm instead going to do, I have that. I know that's a thing I can do. And it returns an integer I saw on Stack Overflow, right? Or a negative number. Maybe it's not an integer, but I'm going to try integer. Okay, int comparison result. Okay. All right, so we do stir1. It's not stir1 though. It's x0 is my first string, or no, xi. My second string was called current smallest. Okay, and then I get back some kind of magic number thing. And if that thing, go back to Google, if it's less than, it returns a negative number. Okay, cool. I'm just gonna say if comp result is less than 0. I don't know. That's just what the internet said to do. I don't know if it works. I could use the debugger. I could do whatever else. But you know what I have done is I've written test. So I'm going to run test sort. Okay. All right, I ran it and nothing happened. And that's good. There's no exceptions, right? So the fact that there's no output is a good thing. There is something saying the program ran, but it finished with exit code 0. That seems to be a good thing. Let me just double check. Let me break my thing. I don't know. Let's do greater than 0 now. If I do that, let's double check. I seem to remember that there's supposed to be an error message. Okay, oh, that's broken now. Changed, but was they. All right. So I feel pretty good that this thing works. I could write tests, more tests to really convince myself, but I feel pretty good. It seems like it's actually generating the right result. I could also step through and see exactly what happens, and I encourage you to try that later, but I'm not going to here. Okay. So what did we get out of this process? We were able to gain confidence that our program works, even though we literally copied and pasted something from Google we didn't fully understand, right? And that's a powerful thing. And what's great about this is that find smallest, while we're not 100% sure that it works, we're pretty sure that it works. So if we're using it in some other program, some other piece, we have a lot of confidence that that piece is like an atomic piece, so we can trust this helper of ours. And again, it's not perfect. We don't know. Maybe we need to write more tests. And actually in lab 3, we're going to teach you how to do randomized tests. So you don't have to hard code all this stuff. But it's like a pretty good proof of concept. Okay. All right. Okay, so there we go. All right, so any questions about this process so far? Yeah. Yeah, so the question was, can a JUnit do other things other than assert equals? Yeah, there's plenty of all kinds of crazy stuff it could do, like assert not null, and lots of other stuff like run this special code before every test, you know, all kinds of different constructs. It's the Java testing library that everybody uses. Other thoughts? Nobody's got a hand on the internet. Okay. All right. So I'm going to take a little quick break from the middle of my flow to talk about this sort of ugly syntax we're using, and then we're going to keep working on sort. So we're going to use something called an import statement that is going to make our tests less ugly, and we won't have to do all this sort of ad hoc stuff like commenting out the tests that we're not using right now. So the first thing I want to point out, just to review the new syntax we've seen, new syntax piece number 1, There's going to be 3 in this class lecture. One was org.junit.assert equals expected actual. This tests that the expected thing is equal to the actual thing. And if it's wrong, then the program will terminate with a nice, beautiful, verbose error message that is useful to us. There was also assert array equals. There's also, to your question, assert false, assert not null, and other things like that. And let me get rid of this box, internet friends. So we've seen that. And yeah, so JUnit does a bunch of stuff. We are, for legacy reasons, using JUnit 4. This semester, we actually switched over the jar file we give to you guys to also support JUnit 5, but they're very similar. So next semester around, I'll change all the syntax to be JUnit 5, but it doesn't really matter which one you use. It's like, instead of called org.junit.assert, it's called org.junit.jupyter.test.assertions.assert equal. So it's like almost the same thing. Anyway. And I do want to note that there's other things that I mentioned to you that you can do with JUnit that are super fancy. Like I wanted to throw a specific exception, but we don't know enough Java for any of that to be useful. So it doesn't matter. But JUnit does everything you might want to do with tests ever. Okay. Now I want to show you some better JUnit. Here we're going to get some new syntax. So the messages that we were getting in JUnit, they were useful. They were these like green text that said expected changed, but got they. But it looked ugly. Like that text was kind of like, I just didn't like the way it felt aesthetically, honestly. And I think aesthetics really matter. Like the difference between a life that is good and a life that is bad often boils down to a sense of aesthetics. It's why people go on vacations and stay in the fancy room. It's why they try to work really hard to have nicer places to live. Aesthetics are really important in life, and I'd say in programming. In fact, I really like this color scheme. Maybe you don't, but I put a lot of effort, into making it beautiful for me, and I guess by proxy you. So I want to fix those aesthetics. I also want to deal with the annoyance of having to comment out tests I don't want. And so now I'm going to show you something that is going to be just a totally weird piece of syntax that is not going to fit in any of the frames that you have in your mind. So I'm going to go to every test, and I'm going to say org.junit.test with an @ before it. And this is basically a little clue to the interpreter and compiler that this is a test. This function is a thing called a test. And it's labeled. It's like it just stuck a pink Post-it with purple polka dots on it. Okay. And there's some code that's going to be looking out for those pink Post-its with purple polka dots. And the other really weird thing, and I don't understand this at all, but I have to delete the word static. Okay. All right. So I delete static. And then the last thing I'm going to do is I'm going to delete the main method because it's no longer useful. But Josh, didn't you spend the whole first week saying there has to be a main method? Well, what there is, it's just not shown on the screen. Okay. It's like once tools get really developed, funny things like this happen. Okay. So as noted, there's a lot of black magic happening here. Just accept it. But the basic idea is that there is a main method that IntelliJ is running in a class that you can't see that basically iterates over the file, finds every function called org.junit.test, and then runs it, compiles its output, and now you'll get the nicer aesthetics. So I run this thing, and now I get, ooh, this is pretty nice, right? Okay. I got an X for test sort and a green check mark. And my success is right there, like looking at me with just beautifully embellished with this green check mark. And you get hooked on the check marks. It's like, I want the check mark, right? So that's the idea behind, one of the ideas behind testing. It's like your own personal auto grader, okay? If you like to see your score on Gradescope or whatever go up, now you can do it at home. All right. Okay. And the other thing that's kind of nice is you'll notice that the output actually looks better now. It's still not beautiful in IntelliJ. Maybe it's the colors. I'm not sure what the deal is exactly, or the font, but we get arrays first, differ to element 0, expected changed, actual they. And you can click to see the difference and then actually see, well, that one's not very useful, but in other circumstances, it could be nice, like on Project 0. So for those of you who have already jumped into Project 0, hopefully many of you, that's what's going on with those files we provided you. Okay, any questions about this? All right, let's continue our journey. One more thing. Oh, actually, I want to mention, okay, so this is just the slide version of what I said out loud. This is there for the world saying, hey, you've made a game that you can try and win, get all the check marks. And the last thing I want to show you with these syntax is, it is pretty annoying to say org.junit.test or org.junit.assert equals. So what I'm going to do is every test file in our class, I'm going to start it with these 2 magic lines of code. And later you can learn what they really mean if you'd like. And we'll have to a little bit when we get to maybe about week 4. But if I say import org.junit.test, the line below means we can just say test. And our code will automatically know it refers to org.junit.test. Okay. So now I don't need this now that I did import. Okay. That's good. And then the other thing I can do, and this one's going to make you even more upset, is I say import static. Okay, this is the third different type of static we've had in the class so far, but so it goes. So we have org.junit.assert. That's one for each day of class. So we have import static org.junit assert. And what this means is that all the methods of the org.junit.assert class, which are static, can now be used without having to have this fully qualified name. And that's a term I just used without introducing it. Instead, I'm going to delete this. And this is what normal testing code will look like. Some people frown on these big star imports, which you might have seen in a previous class, but I'd say that the Java community generally finds this okay in the context of JUnit testing. Okay. Not that that was very exciting, but I just wanted you to see the journey as we made this code more idiomatic. Okay. Any questions about this? So for the real import statement heads out there, unlike Python, you don't have to import something to use it in Java. If Java can find it, whatever that means, it allows you to use it. But in Python, you have to always explicitly import something. So if you want to use TensorFlow or whatever, you have to say import TensorFlow. Or if you want to use regular expressions, you import RE. In Java, everything's out there if you know the long name. So if I say org.junit.assert, I can use anything in the JUnit library without actually importing. So importing is mere convenience. It shortens names as opposed to provides capability. Kind of interesting. All right. Okay. So let's continue on with our selection sort journey now that our tests look a little nicer and now that we have another test to try and finish up here. Not the only one. Okay. So let me just summarize what we've done so far. So we have a visual picture. We created test sort. We created a bad version of sort that doesn't do anything. We created test find smallest. And then we wrote a find smallest method. Along the way, we had to Google to find out how to compare strings. And after we were passing this test, and it was working, maybe I should have made it a different color. That'd be a good idea. All right, spring, which I'll probably call fall. So we'll add callback. Anyway, after verifying this class worked, though, we then made our code nicer with this image. So next what we're going to do is we're going to write test swap and swap, and then we'll be pretty close. So back into testing. This one we're going to do super fast because swapping is a pretty basic operation, but we're just going to do it anyway. Test public void test swap. Okay, string. We're going to take our favorite input again. Okay, they changed the system. Now we're going to do this. Okay, they changed the system. Swap input. I'm going to define, I guess, here 1, 3, just arbitrarily. Sort.swap. Okay, we haven't made that function yet, so it's in red. And then we expect. So if I'm swapping positions 1 and 3, it would be they system the changed. There we go. That's what we expect to happen. And then we'll do again, assert array equals expected input. Oh, after, I usually like to put my expecteds up here. So after I do the swap, that's what we expect. 1, 3, yeah, it looks good. Okay. Now tests can of course have bugs, but if this is so simple, hopefully we don't mess it up. Okay, now let's make this method. Or can we do like create method? Yeah, cool. All right. Oh, I didn't have the right parameters, but I'm going to call this A and B. All right. Thank you, IntelliJ. The keyboard shortcut I just used was Alt Enter. Okay, so how do I swap? I'm going to do just a silly bug. You can spot the bug maybe immediately, but I'm just going to have this very silly bug so I can show you why the test is useful. Okay, so if I run test sort. Now I'm going to have 3 tests, and we're failing test sort and test swap. Okay. So the problem was changed and system. Okay. So what's the problem? And again, I'm just going to use the debugger here. I'm going to put, so I know this is a very contrived exercise, but I'm going to click the debugger here, and I'm going to end up on this line when I run the tests. I'm going to click the visualizer, which came with our, that we had you guys install. Thank you, former TA Eli, for writing this thing. And this is right here, our input. And so when we click this line, we see they system, the system. We see the word system is doubled up. So if you weren't really sure because you're sleepy and you're just trying to finish an assignment at 11:59 at night or whatever, then you immediately like, oh, okay, I get it. Like I see what I did. Oops, I forgot to like set it aside. Okay, this is a rookie move. So I'll set up the string called temp that holds A, and then I'll do something like this. Okay, that's probably right. And even if I'm not sure if I messed it up, again, now I can just run it, test it out. Okay, I'm passing the test. Okay. That's a small debugging. Yeah. Right. Can you do a simultaneous thing? I don't believe it's possible, but like, can you do like one of these? I find it highly unlikely that this will work in Java, but because I think it does. I think the Python version relies on a construction of a temporary tuple. Here it doesn't happen. Yeah, no such luck. If they're integers, you can XOR them, whatever that means. Anyway, without having a temporary variable, but I won't tell you about that today or ever. Except I just did. All right. Okay. So we've now written swap. We used the debugger to fix it. And yeah, it was a little silly. It wasn't a real thing, but so it goes. I really need to get rid of this thing. Sorry. Got to remember. Okay. So now we have all the helper methods we need. And crucially, we have the tests that make us feel that they work. So all I got to do now is write sort. And I'm going to do that by first trying just the first swap. And this isn't so uncommon. Sometimes people call this red shirt programming, where you just sort of jump in like the people with red shirts from the original Star Trek, which I basically never watched, but I know they go to the planets and die at the hands of like monsters. And so we're just going to jump in and write our first swap. So I'm going to do string smallest equals find smallest x. And then I'm going to try and do a swap where I say x, and then I'm like smallest, and I'm like, wait a second, hold on a second. This doesn't seem right. Like swap takes an integer and find smallest is a string. So what happened here is that we weren't necessarily planning ahead well, and that's okay, right? The problem is that we didn't quite catch that. Swap takes an integer argument like 0, 1, and we can't put like, they here. So we have a mismatch just in our thinking. So the most natural way to fix this, I'm just going to spoil this because it's too boring to have you guys think about, is to change find smallest so that instead it returns the integer or the index. Okay. And so to do that, I'm going to change this and say this is now an int. Current smallest is going to be 0. And again, the point here is I'm just going to do it really fast. Let's see, we want x current smallest. And current smallest is now I. Okay, and like I'm pretty sure that's good. I did like a pattern matching thing. It feels like surely it's correct, but of course I could just modify my test and make sure. So I go back to swap. Sorry, I have to make the text big so that it all works on the screens. So there's a lot of scrolling here, sorry. So in this case, the expected will not be changed, but it's going to be 0, 1. 1. Int actual. I'm going to run my tests again. Okay, so I got a little diversion there. But the good news is if I expand this back out, my new find smallest works. Okay. Again, I'm mimicking a process that you might follow trying to solve a similar assignment. Okay, first swap. So let's now swap 0 with smallest. And that should be int. So that's what it might look like to do our first swap. We could use the debugger or write a test just for this thing, but I was just doing this to feel out what happens. Okay. Now what I want to do is like do the rest. Like I want to sort the rest. Well, if I was like praying to the people who made Java, I might say, can I just do that? Right? Like sort the rest using Python slice notation. Okay, that's something if you know Python, that might make sense. If you don't worry about this. That's like, I want the function to do it to the rest of the string. That would be cool. And maybe I need a base case, but that doesn't work in Java. So what would we do? Okay. So I'm going to leave this to you to think about for a minute. You're not allowed to change public static void sort, but I want you to try and make a recursive call that will allow it to sort the rest of the string. Now you might actually just interrupt me and say, why would we bother using recursion? If I used a for loop, this would be easy. Why are you torturing me? Well, it's because we need to use our fancy 61A, 88, E7 skills, our recursion skills. Like it's a really important part of the data structures we learn in this class. So wait, try and think about this. You are pretty much doomed and can't find the answer, but without going to the next slide, but maybe think about it for a minute. I'll give you a hint. Helper method can help. Now, if you're watching the recording, you can actually maybe solve it, but I'm not going to give everybody enough time to really do it. I'm spoiling it. Be gone this thing. Okay. So actually, I'm just going to show you the slide version. There's a pretty clever pattern that happens in recursive array code out there, where you, instead of trying to do a kind of slicey thing, which is impossible in Java, you're instead going to create a method which has an extra parameter that is which part of the array to start at. So instead of having some sort of implicit thing where the language can sub-index into the array, I'm going to explicitly create such an index. So it looks like this. So this helper method is this recursive leap of faith thing that all of you love, especially the ones who are battling their way through 61A with some struggle. This is that idea. So this sort method is going to sort X, and I use the word destructively to indicate it's happening in place. Maybe I'll just say in place. It's going to sort X starting at index K. And so it's going to have some steps. And it's going to end with a recursive call. And then how do you sort the whole array? Well, you tell the helper method, hey, here's an array, and I want you to sort it from the beginning. That's the idea. It feels beautiful. It's like Haskell or something. Okay. So I'm going to change this up. This method is only going to call sort X 0. And what is that? It's public static void sort string X int K. This is a bit mind-blowing. I think the narrative of this lecture makes hopefully crystal clear sense. This is the part where it might be a little bumpy. Okay, so what is this going to look like? Okay, so how do we sort starting at index X? We are going to first find the smallest. Oops, sorry, smallest equals find smallest X. Then we're going to swap K and smallest in X. And then we are going to sort X K plus 1. That's our goal. All right, let's run our code. It's not going to work yet. Okay. We have some problems. Sort. Okay, index 4 out of bounds for length 4. My 61A and 88 and maybe E7 folks. What are we missing? A base case. Okay, what's the base case? I think it's probably something like if K equals x.length, then quit. Okay, let's try running again, see if it crashes. Maybe it's -1 or +1. I think it's probably that. Okay. Actually, I know that it's correct, but okay. All right. So it didn't crash on a recursive call anymore, but now we still have a problem. Expected changed actual day. Ah, crap. What do we do? Okay. So this is where I'm going to walk you through debugging a bit, but actually, let me go back to the slides for a moment. Okay. So even after we use this clever trick with the recursive helper method, and even after fixing our base case, it's still not working. And it's not working at a high level. And this is where you're tempted to post on Ed because you wrote the tests and like, okay, I got changed that. So you do know how to debug to some degree. Maybe you're going to throw in some print statements, but I'm just going to show you a different way of thinking about it. And the way I'm going to do it is I am going to, and I haven't rehearsed this before, so let's see how it goes. I had this idea in response to somebody on YouTube who said this video is bad. So on my bike ride over, I thought, I have an idea to make it better. Here we go. So they changed the system is where we start. If we're doing selection sort, what will happen? Okay, so I'm going to show you over time. So this is start. And what's going to happen next? So after one swap, we expect to see changed the system. Does that seem right? Oh, we're going to make this bigger. Okay. After 2 swaps. Okay. There's only 5 up to as many as 3 swaps, so it's not too hard to exhaustively put out there. So what we expect to happen is changed stays. Then we have the system. What's next? The system, they. Oh no, sorry, they. The reason it's that is because we swap system into they, and then we're done, right? Okay, not so bad. All right, so what I'm going to do is I'm going to use the debugger, which you'll learn how to use in lab 2, but this is a preview. And I'm going to watch what happens after every swap. I'm going to find when the problem happens. The idea is that this test is at too high a level. It's do the whole thing. No, you're wrong. I don't want that. I want to say, okay, show me your work, but don't show me every single marking you make with your pencil. I just want you to show me like each step of your like thinking program. So I'll go to sort and I'm going to set a breakpoint in swap. Actually, no, we're doing in sort. So before every swap. And now when I run it, I'm going to compare reality to expectation. And my goal is to find a high semantic level, just spiritually. I'm looking at this thing. I want to know, when does it diverge from what I expect? And that's why I'm going to use this visualizer. So we have, they changed the system. And then I'm going to skip this swap. So actually, maybe I'm going to go back to my text editor. So, okay, in the real world, so this is the expected behavior. You can do this on paper, and that's probably what I would do. But since we're on a computer, I'm going to do this instead. So the actual behaviors, we have they change the system. After the first swap, I'll step over that. We get change they the system. Okay, that's good. That's what we expected. So far, so good. So the error wasn't there. And now I'm going to click this button that lets me continue. Let's see, what's the actual button to do that? Here we go, right here. It's been a while. So I run back to the next swap. And now we're going to check the next swap and see what happens. Change they the system. I know it's a little small. I don't know how to change the font size. So step over and we get they changed the system. Okay, well, they changed it back. Okay, so somehow we got after two swaps. This is kind of a tricky bug to find. Okay, so it like swap back. Okay. This is what actually happened. So we see, if you had it on a piece of paper, maybe like the two line by line, two side by side, you can see what went wrong. Anybody want to speculate about what went wrong? Yeah.
We moved 2 to 1,
Mm-hmm.
or 1 to 0,
Mm-hmm.
and then we moved over to 1.
Mm-hmm.
And
Right. So we swapped something in here. Somehow changed ended up there. Yeah. We could do another swap actually. Maybe it'll help build some intuition. So next, does it do another swap? Okay. Okay, I'm gonna run it. Okay, here we go. They changed the system. They the change system. Oh, that's really interesting. Like I should never have done that. Like after two swaps, it seems like I undid my behavior, but now that's happening. What's happening here? Let's do one more. I'm liking this. Thanks that person on the internet who didn't like my video. They the system changed. What is going on? Like, let's find the pattern. We're learning something about the behavior of a universe that we ourselves created. We want to understand why it's broken. We're doing it at a high level. What do you guys notice? What's the pattern?
swapping 2 regardless, and then moving down.
Yeah, we're swapping two regardless. I mean, I think there's the cleaner way of looking at it. Yeah. We put it in the reverse order. Maybe the system changed. It did happen to do that. But I want to get a handle on like why is it doing these bizarre swaps? Yeah. Mm-hmm. Right. We're always putting the smallest thing in the index. We first put it in, changed in that position, then that one, then that one, then that one. We screwed up. We're finding the wrong smallest. That's a subtle pattern, maybe a little too puzzling, but maybe it's one way you might find this bug. And often when I find bugs, that's the way I approach it. There's other ways to do this debugging process, though I would recommend not doing the following process where you like go and just step through every single line of code, hunting it down, like, you know, like you can do that, but it's just slow. So what I tried to do was I wanted to create a reality or like set up expectation and then watch reality at a high level. So what's the actual problem? The problem is that we're always finding the smallest thing in the entire array instead of only finding the smallest thing. Like we're not only considering the active green part of the array, we're looking at the whole thing. So what we would really need to do is say something like int k, okay? And we're going to start current smallest at k. And we're going to say I equals k and so forth. So find smallest is now going to have an extra parameter where we only go from k. I'm not actually going to fix my test since we have too few minutes to do it, but let's stick around. We're going to get it. Okay, I'm going to comment away this test. I would really like to fix it and verify that it works, but let's just try and do this. So now I'm going to say find smallest xk, and I'm going to cross my fingers that even without testing our piece that the whole thing works. Maybe it did. We have 30 whole seconds. Okay, look, it worked. Okay, so that's the glory of testing. You may not exit quite yet because I have one more thing to say. Okay, so I I just want to indicate that this process I just followed, I hope it really sunk in your brain as a different way of thinking about writing programs. Tests are incredibly important for making you build confidence in what you're doing. And by judicious use of the debugger, you can make your life a lot better. Now, if you want, I have a bonus video for today on testing philosophy. But at that, I'll leave you go. And thank you, everybody. Hi, how's it going? Good, how are you? Great. Unlike everybody else, I like your